So using the worksheet, start with question 2. Question 2 says, find the perimeter of the rhombus with the vertices P, Q, R, and S. Let me see your attempt. I'll only go to the areas that I think we have not reviewed. Others I will skip. Then we'll look at bisector. We'll look at collinearity, even though there is no question on collinearity in the paper. So it should be a short class, I believe. Bena and Ethan Cheng, can you send to me on your WeChat what time you're available later today? So let's discuss on what you sent to me before. Sorry it took this time. So I even printed the paper and I've gone through the wonderful work you have done. So please send to me on WeChat your time that you're available either today or tomorrow. Okay. All right. Received yours, Mr. Cheng. Ms. V. I hope you send to WeChat, not here. Okay, yes, on WeChat, please. Anytime you're available, today, tomorrow, give me the range of time, then I look at that with my availability so we can discuss. Okay? So I'll just set up a Zoom meeting and we will after 2, this is already, okay. What do you mean after 12? Tomorrow, oh, okay. It's all right, I'll let you know. But you would rather today, yeah, okay, no problem. If I'm able to, I'll put that into consideration as a priority for today. Otherwise, anytime after 12 tomorrow, okay? Thanks for your understanding. Let me see, I have an engagement tonight. Let me see, actually it's just upstairs, so shouldn't take longer. I have an engagement 7:30 to 8 upstairs, Miss V. So give me another option. Lillian, I received your solution. Very good, well done. Okay, Ms. V, tomorrow, 2 p.m. Thank you. Lillian, I received your solution. Well done. So let me pick another question. So Lillian, you can move on with that. Lillian, could you attempt 8 and 9 next? 8 and 9 next. So from the worksheet, that's worksheet 17. Is that the stuff? 18. So question 2, 8, 9. If anybody doesn't know what to do, please say something in the chat room. Krista C, check your solution again. Uh-oh. Krista K, you want to check your solution again. So for question 2, I haven't got other solution. So question 2, I'm going to put the question on WeChat so I can check it on the phone. Tudum, tudum. Mr. Chang, solution received. Well done, sir. Nakita, solution received. Well done. However, Nakita, you only need to find one of the side and write a comment. Yeah, because it is already established there is a rhombus. Yeah, well done. So for those that have issues with that, the rhombus, Charlie, this is a rhombus. Okay, So for question 2, makes an intercept, blah, 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 means, yes, it means it touches x at 2. It means x equals 2 is the intercept. Karen, got your message. Correct, well done. So this is your rhombus for those that have problems with it. And one thing about rhombus is that all these sides are equal. So if this is P, Q, R, and S, all you have to do is find one of the lengths. So if I take PQ, for example, so I use the distance formula. Distance is equal to x1 minus x2 squared, y1 minus y2 squared. PQ will be the square root of, that's what you do. Calista, message received, correct. So if I take PQ, remember my P is, I put it here, -2, -3. My Q is 1, 1. So I can make use of those two only. So making use of those two means I could label them as 1 and 2. So if this is x1, this is y1. If this is x2, this is y2. Then I substitute. So I get -2 minus 1 squared plus -3 minus 1 squared, something like that. Lillian, that one received. I'll check in a bit. Yeah, Crystal, correction received. Well done. Mr. Cheng, I'll check your number 8 anytime soon. Okay, so if you proceed with this argument, this is -3 squared, which is 9, -4 squared, which is 16, so you get 25, so which is 5 units. So if PQ is 5 units, then perimeter is going to be 4 times 5. Units because we do not know if it is centimeter, kilometer, decimeter, millimeter, we don't know, so you put units. Is that taking everyone? So I'm checking the other stuff now. So question 8. Mr. Chang, your question 8. Let's see. So our question 8 says, find the equation of the line parallel to that. Mr. Chang, your gradient is not -5/4x. Gradient is a number. Confirm that you understand what I mean. Oh yeah, okay. So Lillian, checking your work now. Okay. So Lillian, you call them M1, M2, okay? So I need to know, M1 is the gradient of the first one, M2 is the gradient of the second one. Then you have to establish that they are the same. So M of the perpendicular is equal to, so instead of saying so M of the perpendicular is equal to, you call that M1, M2. That's a better notation. Well, very good, well done. Crystal, okay, I think I've told you, I got your feedback. All right, so let's do the question 8 and 9 and see. After 8 and 9, I need you to attempt 18. Should we do 18? Let's see. Yeah. Yeah, do 18 after 8 and 9. So 8, 9, 18. Please ask me a question if some things are not clear. Please do not pretend everything is okay. Today is about practice, trying to remember something and adding more to what we might have known before. So please, some things you may not know, so I will explain. Like the questions on locus, if anyone doesn't know, then I'm happy to explain. So we're looking at 19. Twenty-seven is from your textbook. Twenty-eight also. Or maybe 29 instead. I think I'll add 23 in between. So these are my selected problems to practice. Okay, so I'm going to be solving question 8. I believe we have given enough time for people to attempt, so you can understand the symbol that I'm expecting you to use. Okay, so I'm going to be solving question 8. So please pay attention. Even if you have done it, just please pay attention to what's my expectation of questions of this form. So the question says, sorry, just a sec. Okay, here we go. The question says, find the equation of the line parallel to this, parallel to x plus. So there is a line. So question 8 now. Okay, solution or correction. So there's a line. So I call that maybe L1. Yeah, you don't have to call it anything. I call it L1. So x, or maybe you should, 4x plus 4y minus 1 equals 0. So for this line L1, the gradient will be M1. Okay, so I'm going to find the gradient. Okay, maybe I read the question first. Find the equation of the line parallel to this and passing through that. So this in picture form. This line L1 is like this. There's another line parallel to L1 and it passes through the point 1, 2. So we're trying to find the equation of this second line. Okay? We're trying to find the equation of this second line. That's what it means in the real sense. So I call the first line L1. Someone is saying something. And then that's not, oh, sorry. Thank you. Please speak to the mic next time because I didn't notice you sent in some comments until I started noticing some notification, like orange notification. Okay, so please just turn on your mic and say something. Or if you use the raise hand, whatever, it will come on my screen. Yeah, but the comment I have to, because sometimes the chat is minimized. All right, so it's actually parallel to 5x, thank you. So that would be my first line, 5x plus 4y equals 11. So that's my line L1. Okay, so I find the gradient of this line. The idea is, if you have one line, this is L1, this line passes through what? Oh, okay, we only know that this line intersects x-axis at 2. That's all we know. Which means it passes through x is 2, y is 0. That's what it means. Okay? So basically, to find the equation of these lines, which I'm going to call L2, we already know the points it passes through. All we need is the gradient, and we can find the gradient from here because according to the principle of parallelism, if two lines are parallel, then their gradients are equal. So I'm going to figure out what the gradient of this one is by making y the subject. So the gradient of this line, I call it M1. That is the gradient of line L1. And so M2 is equal to minus 5 over 4 since they are parallel. Something like that. You could just give us some explanation since they are parallel. Okay? So equation of L2, okay? Okay, so we know you are trying to figure out the equation of the second line now. So be detailed, to some extent in your explanation. Equation of L2, because it is gradient point form, y minus y1, mx minus x1. You don't have to find a c. I notice some people are substituting to get the value of c. Yeah, it's a waste of time, kind of. So, okay, remember it passes through, equation of L2, which passes through, you don't have to write which passes through, I'm just putting that here, which passes through 2, 0. So if you substitute, you get y minus 0, m is same m, minus 5 over 4, x minus 2. So this is what you simplify. Y is simply this, minus 5 over 4, x minus 2. Yeah? So what I could do is to clear the fraction by multiplying by 4. So I'll be getting 4y, negative 5, x minus 2. And that gives 4y, negative 5x plus 10. So I could bring that here, putting x first, 5x plus 4y again, this time around equals 10. Okay, so what is important for me in your solution is identifying your M1, identifying your M2 and Y. How you do the rest, how you present it neatly is up to you. Okay, this is very important. Does everybody get that, please? Okay, thank you. So please take note of that. So if you are dealing with perpendicular case, so you just say, so M2 is 4 over 5 since they are perpendicular. That's all, that's enough. You don't have to say M1 times M2 equals -1, solve the equation. No, this explanation solves the equation. This short statement is enough. All right. To check more WeChat submission, if any. None yet, okay. And please do not leave your equation with fractional coefficient, please. Don't leave your equation unless the question says leave your equation in, what's that form? Gradient intercept form. If the question doesn't say that, this is the format I expect to see, okay? You can decide to leave it this way. You can decide to leave it this way. Someone can decide to say -10 equals 0. As long as the coefficients are integers, you are fine. Received from Nakita. Question 9. Can I have the word so? So you have, which implies that M1 is 3 over 2, which implies that M2 equals, okay? So because you are linking each of these together. Nakita, is that understood? Good. So you are linking them because they are different information. Okay, your Y as a subject of formula implies that M1 is that. That M1 implies that M2 is that with additional reason. Okay, because L2 is perpendicular to L1. Perfect. Okay. So Y plus 7, if you could explain what is Y plus 7, okay, something like, so the equation of L2 will be given by something like that, okay, or to find the equation of L2, then you start that way, okay, all right, well done, really impressive. Please, if you have questions, maybe you don't know how to do this, it's not as easy as I thought for you, please message me privately if you must, or you could just post on the group or the group chat here. If you just need extra time, please take your time. All we want to do today is practice, and maybe by 3:30 I'll let you go. All right? I just want you to practice with me being online. Okay. Miss Karen, got your solution? I think we already discussed this, so I noticed your solution also is similar. Well done. Oh, I like that symbol. Since L1 parallel to L2, you use the double slash. Wonderful. That's allowed. Substitute. Don't use sub. Sub could be subway, Karen. Are you talking about subway or substitute? Don't use the word sub. It could be subscription. Okay, so don't use sub. Karen, good. Understood? Good, all right. So then use the word sub. Substitute that into that to find L2. Not to find L2, Karen, but to find equation of L2. Okay? To find equation of L2. Nice explanation. Good. All right, well done. I'll be expecting more solutions from you guys. I will be working on, so Daniel, can you go over 5A from the textbook picture you sent? Okay, sir, so I'm going to check the 5A question. Yeah, steady gradient, perpendicular bisector, steady gradient bisector. All right. Okay, that's easy. It's part of something we are trying to do today anyway, so. We'll be looking at that. Maybe I'll open the next slide to do that. 5A from the picture that I sent to you. That's from the textbook. Right back. Crystal okay? Good. Well done. Detailed solution, Crystal. Crystal C. Crystal C, instead of saying gradient of the other line, I've given you the notation to use, M1 and M2. What is D? Put 37 into the equation. Now, your solution isn't clear, miss. What's after question 9? Oh, sorry, that's my chat box. Is that what you see? Sorry. Sorry, Crystal. Thank you for bringing that to my notice. It's a group chat, so I try to put it on the screen. So you can't see me? Can you see me? Okay. Yeah, Clarissa, got your work. All right. Oh, okay. What do we have on this side? So I'm at the top, right? That's weird. Anyways. So now that I've received question 9 from lots of you, I haven't got from Calista, Leo, Brandy. Please do not try to solve all the questions before you send. I expect you to solve one by one and send to me. Since the line is perpendicular, 3/2 is 1 over that. No. M1 is not equal to 1/M2, Calista. It is negative of it. And I told you not to do this. This is why you get yourself confused. Right, last class I said change the sign, negate, and flip. I don't need you to solve this equation. I mentioned that last time. So you have used the wrong gradient, and so where does the minus come from? Okay, you used the right gradient, but you wrote the wrong thing at the top. Can you please adjust that? And you don't need to go through all that. So the moment you get your M1 equals 3/2, I expect you to say M2 will be negative 2/3 since they are perpendicular. That's all. I don't expect you to say 3/2 times M2 equals either 1 or -1. I don't expect you to see it. So this is all you need. I don't need this. Okay, all right. So Leo, I'm checking your work now. You should always send your work. Most of the time you don't send in your work in my class, and I don't like it. If you don't send your work, there's no way I can correct you. And if I don't give you a correction, there's no magic. How can you improve if you don't get a feedback? And you can't get a feedback unless you send in the work and I can give you a correction. So please, you need to adjust that. Your M1 is not 3x/2. Your M1 is 3/2. X is not part of it. X is never part of it. So why is L2 having 1/4? So for L1, you wrote the equation, and you got that, and eventually you got negative 3/2 plus 3x/2. Your M1 is the coefficient of x because it is y equals mx plus c, or y equals c plus mx. So it is this number before the x. So basically what I'm saying is your M1 is 3/2. There's no x here. And now L2, are they perpendicular or parallel? Nothing is written here, Leo. Look at my example, it's on the board. In my example, after I get my L1, I wrote something. I can't even see that. Since this, M2 is equal to this, is not here, and you tell me you have done, you have a feeling you have done something wrong. Of course, it's not just a feeling. Compare my approach to what you did. Ethan Cheng, I'm checking your work. Please, can you send your picture with, capturing the page? I'm not trying to capture your entire table because I have to zoom in and it's so difficult to see. Please send that again, Mr. Cheng. Krista, correction for number 9. Krista, I need to turn my neck around next time, please. Even when I turn this thing, I still need to turn the computer, the phone changes the orientation immediately, so I have to turn my neck. Please, can you send that correction in a portrait format? Thank you. Number 9 is seen from most of you. Thank you, Mr. Cheng. This is better now. All right, looks okay. What question is this? 18. Okay. What's question 18 again? Okay. Good. That looks good. That looks good. I didn't check your simplification, but the steps are exactly what you should do. Krista, got your solution now. Why are you putting 3, 7 into the equation? Okay, y is equal to mx plus c. All right, so call it c, not d. I guess that's why I was confused. Just call it c, not d, Krista. Krista C. Please take note of that. Lillian, I'm checking. Okay. Gradient of MC. So you wrote M of BC. All right, you can do that. What you could also do is this, Lillian. You wanted to say gradient of MC, right? Gradient of BC. You can use a subscript, or you can say M of BC the way you have written it. That's fine. Akita, what came in? I see what? Can see you. Okay. Oh, that was a long time message. All right. M1, you call it M1, good. So you have the equation. Okay. I don't have the answers in my head, so I'm just looking through what you did and how it makes sense or not. You know what we mean by general form of equation? Okay, let me see. What question is this, Nakita? 18. Question 18, determine.
I think I write wrong, like it's the gradient intercept form, is not the general form.
Oh, okay. Oh, okay,
Yeah.
okay.
Oh, I need to change.
You're trying to use that to get the gradient. Is that what you're trying to do?
I think for like the part 2, I wanna use them to find the intercept
form. Oh, yeah. Okay. That's fine. Oh,
yeah,
okay.
I will change like the general form.
Okay, perfect. Well done. Thank you. That makes sense now. Okay, good. All right. I've seen a lot of attempts. Wonderful. Brilliant. Very good, very good. Okay. Krista K, something came in from you. Well done. So what we'll be doing to make it easier is to check our answers together so we do not waste time. So before then, what I will do is the 5A question that Ethan was talking about from last class. And also Krista mentioned another question. Mr. Chang, when you say 5A from the picture I sent, right? So which is a line We ask equation 3x minus 2y. Please confirm, is that what you mean? No? So what question? You said question 5a. That's what I have in 5a. Okay. Can have more than 1 second. I'm still enjoying my bread anyways. And I don't share, please do not. 7a. Or maybe B. Okay. From the picture sense, you guys remember this? A is that and B is that. Remember this? Consider the points A and B. Show that the equation of the perpendicular bisector is that. I think before we do this, we should talk about question with equation of perpendicular bisector. Let's talk about any question that has to do with equation of perpendicular bisector. Let's talk about that first. Which of the questions that we're doing at the moment has that? I think question Question 18 is like that. So maybe we consider 18 together. 18 from today's worksheet. So you have 18, you have A, 7-1, B, 6-4, C, 5-5. Find the equations of the perpendicular bisectors of AB and AC. So there are two questions. One is for AB and one is for AC. So if I sketch this shape, so maybe X is 7, Y is 1. I'm trying to get a sketch, okay? X is 7, Y is 1. X is 6, Y is 4. So maybe this. So this is my A, this is my B. Then X is 5, Y is 5. Then this is my C. So something like this. Okay? So we are looking at the bisectors of AB and the bisectors of AC. Is it AC or BC? AC, all right. Bisectors of AB, bisectors of AC, and we're trying to find where they meet. Bisectors of AB will be this, and bisectors of AC will be that, and both will meet at this point. So this is all about question 18. Does this make sense? Okay. Talk to me, guys. Do you understand my sketch? Before I begin, I'm trying to get a picture of what it is. Okay, that's basically what I'm doing. Of course, this is not parallel to x-axis. It's just a way of writing. So what I would do is try to understand what does perpendicular bisector mean. Okay. Perpendicular bisector means it meets at midpoint and also it's at 90 degrees to the line. At 90 degrees means the gradient, these two lines are perpendicular, basically. So two ideas we need here. The idea that what happens to gradient of perpendicular lines and the idea of midpoint, which you should have done before. So for AB, if you want to find the perpendicular bisector of AB, you first need to get the equation of perpendicular bisector. You need the gradient of that bisector okay? And you need a point where it passes through, okay? You need the gradient of the bisector and the point where the bisector passes through. The gradient of the bisector will be the negative reciprocal of the gradient of AB because they are perpendicular lines. The point where it passes through will be the midpoint of AB. So the first thing is to find the midpoint of AB. So midpoint of AB will be 7 plus 6 over 2, 1 plus 4 over 2. And that is 13 over 2. No decimal, please. 5 over 2. And this is because the midpoint of a line segment is x1 plus x2 divided by 2, y1 plus y2 divided by 2. This is how to find midpoint, in case you don't remember. So we have the midpoint. Now the gradient of AB. So m of AB, I call that m1 in this case, okay, will be y2 minus y1, x2 minus x1. That's what I'm using. Y2, I could use 1 minus 4 or 4 minus 1, it doesn't matter. But if I use 1, I have to start with 7 here. Negative 3 over 1, which is negative 3. Okay, so M2 will be 1 over 3 since they are perpendicular. When I say they, I mean AB and the bisector. So equation of perpendicular bisector to AB is y minus y1 mx minus x1. So y minus y1 will be y minus, it passes through the midpoint. Remember, the bisector passes through here. This is the midpoint. This point is here. Okay, y minus 5 over 2. M is this is the gradient of the bisector. Okay, this is the gradient of AB. That's the gradient of the perpendicular bisector. 1 over 3, x minus 13 over 2. Okay, so this is what we simplify. I can open the bracket first. Then we can multiply through by 6. Then we can write it properly. 6y minus 2x equals 2. Okay, and the next question is, oh, there are 2 questions in 18 Roman figure 1. So this is just for bisector of AB. Now we get the bisector for AC. I can remove these coordinates. This is enough sketch. The sketch is not compulsory. It's just to give an idea what you need to do. You don't have to sketch, but it gives a clearer picture. So gradient of midpoint of AC now.
Mr. Daniel?
Yes, ma'am.
It should be BC.
The question is BC?
I think so.
No, check the question. I'm looking at AC in my worksheet. Please confirm.
Oh, yeah. I saw wrong.
Saw the wrong one. All right, that's okay. So we have that 1 plus 5. So please check my workings in case I made any mistake. So that should be the midpoint. So midpoint is here. Okay, here. Okay. So this point is here. So that's where the bisector passes through. Now we need to find the gradient of AC so as to know the gradient of the bisector. So my MAC is my, I don't want to call it M1, M2 this time, so I can use 3 and 4. Okay, MAC will be my M3. So we're going to do Y2 minus Y1 again, A and C. So I could use 1 minus 5, then X, 7 minus 5. So negative 4 over 2, which is negative 2. Am I right? So this implies that M4 is 1 over 2 since they are perpendicular. Something like that. Okay? So equation of AC, equation of bisector, sorry. Equation of perpendicular bisector of not 2, of AC. Okay, will be Y minus Y1. This is where it passes through. Now Y minus 3, gradient X minus 6. This implies Y minus 3, half X minus 3. Minus 3 cancels, so Y equals half X. That's the equation, okay? Or you could say 2Y equals X. Or I can say 2Y minus X equals 0. So you need to solve this and this simultaneously to get the point of intersection. What do you guys get for the point of intersection? For those that did it. Anyway, the point of doing this problem is to be able to address this general, the so-called complex problem from 7a. So we need two things to find equation of bisector, as you can see. What are the two things that we need to find equation of bisector? Equation of perpendicular bisector. Yes, talk to me, please. Midpoint, that's 1. Then 2. Gradients, yes, gradients and midpoint, good. So that's what you need to do here. So midpoint of AB. So midpoint of AB will be x1 plus x2 divided by 2. Yes. Then y1 plus y2 divided by 2. That's all. Gradient of AB, y2 minus y1 divided by x2 minus x1, which means M2, which is the gradient of the bisector, will be what? Anyone? Yes? What will be the M2 in this case, gradient of the bisector? I can't hear Brandy's voice or contribution. Karen, Callista. So negation of that. So that would be minus y2 minus y1. No. Negative flip. Please tell me if you understand this or not before I proceed. Okay. So, and the reason is Okay, so now equation. Will be y minus y1 the gradient x1 let's see. Okay, that's not a simplified form. If you look at what you have is to show this x2 minus x1 x y2 minus y1 y equals to x squared plus y squared minus x1 squared. Where does this 2x1 squared 2 squared come from? Okay, we'll see. Minus, this is in bracket, then x1 squared plus y1 squared, everything over 2. Okay, so we open this bracket definitely, or multiply through by the LCM. Yeah, so our LCM is twice this. You agree, everyone? Our LCM is 2 times this. Okay, so if you multiply through by that, so I'll say multiply by 2y2 minus y1. So if you multiply by this, it's going to be 2y, y2 minus y1. Multiply by this, 2 is gone. So I'm going to have y2 minus y1. Then I have y1 plus y2. That looks like difference of 2 squares. Anyway, we can see yet. Equals, multiply this by 2, I have negative 2. Yes, negative 2. Yes, x2 minus x1. Then I still have in the bracket. Because this is a term. So when I multiply, I only multiply by this. If I open the bracket, 2y, y2 minus y1, y2, please call my attention to any abnormality that you see. If you open this, negative 2, x, then open with this, 2 cancels 2, you have plus x2 minus x1, x1 plus x2. Okay, what do we notice? So this can be easily deduced because we can have it here and here. So let's take them away. If you take these 2 away, I put the x term first. I have plus 2x. Okay, if you notice, x is at the back. Okay, but I write it first. And 2y. Then here x comes first, right? So I write x2 minus x1. Then I'm going to rearrange this. Addition is commutative, so it doesn't matter which one comes first. Then I bring the y term. y2 minus y1. Can somebody tell me why I've decided to rearrange them? Can someone tell me why I've decided to rearrange them, please? Looks more like the goal. Not really. Think again. Factor out 2. Not really. Think again. Difference of 2 square, yes. I'm trying to get difference of 2 square. I don't know how that might help me, but I notice a pattern. So I'm trying to make it look like difference of 2 squared. So this is going to be x2 squared minus x1 squared, and this is going to be y2 squared minus y1 squared. Yes, and that can help me because I can bring the y2 and x2 together. Yes, that helps me now. So x2 squared plus y2 squared minus x1 squared minus y1 squared. Okay, so what does this mean? It implies that two x, actually I can divide by 2, or before then, x2 minus x1 x 2 y2 minus y1 y is equal to, so the first one, x2 squared plus y2 squared, and the second minus can be factorized. If I factorize minus, it becomes plus. Then I can divide both throughout by 2. Okay, if I divide throughout by 2, you can see this 2 comes here. Can you see that? Everyone understood? So now we achieve the goal. Now we achieve the goal. Now we achieve the goal. So it's going to be x2 x1 x y2 minus y1 y equals to x2 squared y2 squared x1 squared y1 squared, everything divided by 2. This is what we're trying to get. So just one advantage of writing this in general form. Anyone? So just one advantage of writing this in general form. Anyone? Can be easy to find intersection between two equations, but there are no two equations here. There are no two equations here. Midpoint separately, not quite. Anyone else? Can I have, we don't have to find gradient. Oh, okay. What do you mean by that? Wait, oh, okay. How about now? Can you see now, Crystal? Not really, still covered. How about now? How about now? Still covered. Better, okay. Okay, so somebody said we don't have to find gradients. Remember, the general form is ax plus by equals c, something like that. So now, this is like your A, this is like your B, and this is now your C. So just one advantage of writing this equation in general form. So let me read your comment again. We don't have to find gradients or midpoint separately. Well, Lillian, what do you mean by that? Because to find to write this equation in general form has nothing to do with your gradient or midpoint. So we can find the point of intersection easily. No, I don't think so. I think it's just to make the simplification easier. Okay, perpendicular bisector, I don't know. I think it's just to make the simplification easier as far as I'm concerned. Okay, let me check some of their suggestions. That's question what? Okay, let's check their suggestion together. Question 11. Finish sharing. Question 11 of exercise 1C. Can everybody see my screen? Oh no, not this. That's exercise 1C. Is it? Yeah, 1C. Question 7, not 11. Okay, almost there. Yeah. This silly reason, come on. We can find the perpendicular bisector of any two by substituting that. That's so, I don't know, doesn't sound like I was expecting. Oh no, sorry. Is it? Do you guys understand what I'm looking at here? Can you still see the board? Okay, yeah. So I was expecting something more concrete. The reason to leave this in whatever form is to substitute the coordinates. So basically what we have established is a formula. We can just substitute x1, y1, x2, y2, and the equation of any perpendicular bisector given 2 points, x1, y1 is easier. Anyway, can you see the reason given, everybody? Please take note of that. Let me see if I can take a picture and post it to you guys. Now, so we can substitute basically. So you can take a picture of that and save it and write it later. Anyways, quickly, I want to talk to you about locus. It's one of the questions I gave you. Has anybody been able to try question 19? Talk to me, please. Question 19. Does everybody have idea? Reply if you have an idea or not, what that means. Okay, so I just want to be sure. Yeah, find the distance. Yeah, basically that. Basically that. I got a message. Nakita, I got your message. I'll check later. Yeah, it's about distance. So this is what locus mean. You must have done construction in the past. Yes? During your IGCSE classes, did you do construction? I'm sure we did, because I taught some of you myself. Can I get response, please? Whenever I talk to the class, I need the response. You remember Locus from your construction classes? It's a question of Locus. Equation of locus. So in your IGCSE classes, we told you that the locus of points, which is equidistance between 2 points, A, B. Somebody just got disconnected. Can everybody still see me? All right. Okay. So equation of the locus of points. Locus is like paths, okay? So basically, Wi-Fi dying, sorry. You can watch the video later if you cannot. Okay, she's back. So locus is like a path. So asking you to find the locus of points, which is equidistant from a fixed point. Basically, from these 2 points. This point will be equidistance between them. This point will be equidistance like this. They will be of the same distance. There will be another point somewhere which is the same distance from A and B. If you come down, there will be another point equidistant from A and B, like that. So find the locus, okay, or describing the locus is telling you what part does this point, what does it form, like a shape, does it form? It forms a straight line, which is a perpendicular bisector. That straight line bisects the line joining AB. Do you understand? So one of the locus we discussed in IGCSE class is that locus of points equidistant between 2 points is the perpendicular bisector. Locus of points equidistant between 2 lines is the angular bisector. And the locus of point which is certain length from a point, certain length, maybe length 2 units from a point, that is always 2 units from a point, is a circle of radius 2 and center of that point. Do you guys understand this? You remember this from IGCSE class? Okay, so the equation of locus in this case is simply about distance. So it's nothing you should worry about too much. One of the question 19 says, find the equation of the locus of point, which is equidistant from 2, 3, and 4, 5. The locus, equation of the locus of point. So the point is P, okay, point PXY. This point is always equidistant from, so PXY equidistant from A and B. A is 2, 3, and B is 4, 5. We're looking for the equation of the locus. Remember, these are 2 points. You can actually tell me what this will be. What is that locus? What is the locus of the point that are equidistant from A and B? Anyone? Even before we do anything, you should be able to tell me what that says. The locus is not midpoint. The perpendicular bisector, yes. We just talked about it. It's still on the board. Is this case 1? If you have 2 points, you are looking for the shape that the set of points that are always of equal distance will form. That's the point. Okay? So this point that are always of equal distance from here, one of them is at the middle, One will be here, one will be here, something will be here. These are all the points, infinitely many of them, that are of the same distance between these two. You will notice that this point will form a path. And when you join all these points, you form a straight line, which happens to be the perpendicular bisector of the line that joins the 2 points. That's why we say the locus of point equidistant from 2 points is the perpendicular bisector of the line joining the 2 points. Does this make sense, please? Can I get a yes or no from the group? So because these are 2 points, don't be deceived. These are 2 points. It's exactly this case. Okay? It's exactly this case. So even before you do it, basically you're looking, by the time you solve the problem, you're actually finding the equation of the perpendicular bisector. So which means this is a shorter way of finding the perpendicular bisector. Let's see. So what you need to do is let P be the point that are always of the same distance. If P is the point, then the distance between PA, P equidistant from this, and this implies that the distance PA is equal to the distance PB. Okay, P is of distance between A and B, means if this is A and this is B, P is somewhere, that's just that this and this are the same. And what does this mean? It means you can square both sides. Do you agree? Can somebody tell me why I've decided to square both sides? Why did I square both sides? Anyone? Talk to me, please. Don't waste our time. 13 minutes to the end of the time. Distance formula is in square root? Yes. So to avoid finding square root, I square both sides already. The distance is the square root of something squared, something squared. So if I square both sides already, I'm just dealing with this. Understood? All right. So PA. So from P to A, X is X1 here, 2. Can you see that? Then Y minus 3. PB, X minus 4, Y minus 5. So you expand. X squared minus 4x plus 4, y squared minus 6y plus 9, x squared minus 8x plus 16, y squared minus 10y plus 25. On both sides, I can cancel x squared. On both sides also, I can eliminate y squared. And now I have minus 4x plus 8x minus 6y plus 10y, 16 plus 25 minus 4 minus 9. So this is 4x plus 4y, 16, actually 9 minus that is 16, 32, 28. Please confirm. Please confirm, is this right? So that is the equation of the locus that is equidistant. This same question is actually asking you to find the equation of the perpendicular bisector of AB. Is that right? Talk to me, guys. Is it true? Yes? Aha. So if you are to use the method that you know about perpendicular bisector, find the midpoints. Midpoint will be 2 plus 4, 3, and 4. Right? 2 plus 4 is 6, 3 plus that is 8, so you have 3 and 4. The gradients of AB Change in y is 2. Change in x is 2. The gradient is 1. So which means the other gradient is -1. Y minus y1, x minus x1. What do you notice? Y minus 4, negative x plus 3. So y plus x equals 3 plus 4. You still get this back. Can you see that? But this, you can only, if you have this problem, you can say, you can use this locus approach, but you have to explain why. Find the equation of the perpendicular bisector of A that and B that. Oh, the equation of the perpendicular bisector is the same as the equation of the locus of point equidistance from that. Then you use the distance formula, and that will be allowed instead of finding midpoint and putting it back. Okay? Does that make sense? So basically, locus is about finding the shape. In this case, the next question might be describe the locus. That you can describe, oh, the locus is a straight line. If I'm to describe, okay? I don't know if I put any question that says describe the locus. Okay, it is a straight line, okay, which is a perpendicular bisector of line AB. That's a description. It means tell us about it. What does that mean? As a description, okay? If you come across something like x squared plus y squared equals maybe 16, how will you describe the locus if this was the equation of, if this was the answer? Anyone? Guys, I'm waiting. Talk to the mic preferably. If at the end of the solution here, you got something like this, and the next question is describe the locus, what would be your response? Can anybody hear me, please? And I prefer you talk to the mic. It is a, is that a circle? I don't know, you tell me. I'm asking. If at the end of the whole thing you got this, what would you say is the description? And I prefer you talk to the mic, please. Thank you. Class. Don't send me a message on WeChat. We're talking about stuff in the class. Can anybody hear me, please? You know, this is what I do not like. Absolute silence. I do not like it. Okay, somebody said it doesn't know. Trying to think. So I have response from 2 people out of 11. What happens to the other 9? Trying to think. I see. It is a circle, like you said, Lillian, but that's not a complete statement. So can you give me the complete statement? What? It is a circle, but say something about that. More information. A circle, what are the properties of a circle? If you are talking about, you are describing a circle, what are the major things you must tell us about the circle? Come on, guys. What are the properties of a circle that you must talk about to describe it completely? No, these are specific stuff. Don't bring in that formula.
Is it all points of the circle are equal distance from the center point?
That's what makes you get the locus. I'm saying, what is it about a circle? It has nothing to do with high school. What is it about a circle that we must always talk about? It's a part, is a significant part of a circle. What are those important features of a circle? Anytime you mention a circle, something has to be mentioned. Two major things must be mentioned. What are those two major things? The radius, of course, that's one of them. And what else? No. Then just the origin, the center. We don't call it origin, we call it center. It is origin if it is 0, 0. The center may not be origin, okay? Every origin may not be a center. So in this case, if you use the formula that I think Krista just wrote here, if you use this formula, it means your H is 0 and the other, what is the other letter you used? Your K is 0, which means the center of this circle is origin. And the radius is what? What's the radius of this circle? What's the radius of this circle? 4. So when you're describing the locus, it is a circle of radius 4 and center origin or center 0, 0. That's your description. You have to be able to tell us what it is. Is that clear? So in a similar way, you could find this, obtain the equation of the locus. So I'm going to share this with you quickly so we can go. If you look at question 20, all you have to do is just simplify this, that's all. It's as simple as that. Okay? In this case, I said describe the locus. Okay? Talk to me. Is that understood, everyone? So question 19, 20, and 21 are problems on locus. Oh, there's another one here. 22 is on locus as well. Okay? So up to 22, these are locus-related questions. And that's all about the things that I didn't mention. So please attempt the rest. Okay? Attempt the rest. I'll ask you to find out what do we call collinear points. Okay, we might solve one or two problems on Monday. Hopefully we can start something new on Monday, otherwise we will have to do it another time. Okay, so find out, because I want you to also know that when do we say when do we say 3 points are collinear? Okay. When do we say 3 points are collinear? Or does anybody know, so we don't have to waste time? Anyone? Yes, when they lie on the same straight line. Thank you. So 3 points are collinear when they lie on the same straight line. So if I give you 3 points, x1, y1, x2, y2, x3, y3, how do you know if they are collinear? Anybody? Lillian already said when they lie on the same straight line. Can somebody else think? So if the 3 points are collinear, yes, their gradient must be the same. What do you mean the gradient? Gradient of what? Don't just say the gradients are the same. What gradient? Gradient of what?
The gradient of the 3 points are the same.
We don't talk about gradient of 3 points. We talk about gradient of a line. Yes, Brandy. Gradient of AB and BC must be the same. Or gradient of AB and what? Nakita, can you complete that? Brandy already said AB and BC. It could be also gradient of what? Basically, the gradient of any 2 points. Yes, the gradient of any 2 points must be the same. Okay, gradient of any 2 points must be the same. That's how we do collinear points. Okay, so they must lie the same straight line. It means the gradient must be the same. So I'm going to write it this way: gradient of AB must be gradient of BC must be gradient of AC. So all you have to do is choose any two. I can decide to use AB and BC, or I could use BC and AC, or I could use AB and AC. You don't have to show all the three. Once you pick any two of these three. If any two of these three are equal, then those 3 points are collinear. Any questions? Another way is to look at the distance. If they are collinear and you are sure of the positions, you can say the distance of AB plus BC must be the distance of AC. Because if it is not collinear, it is unlikely that the distance of this plus this will give you this. It's not possible. All right? Does that make sense? If this is A and this is B and this is C, if they are not collinear, this distance plus this distance must be greater than this one. Okay? So then that's how you can disprove collinearity. But if they are collinear, distance here plus here must be equal to that. But that's a long way. If you are using distance, it's too long. So gradient is easier. Questions, please, before we go? So I write here collinear points. Collinear points. So that's the last thing I want to bring to our notice, collinear points. Okay. We can use gradients or we can use distance. But the distance is a long way. Okay, if there are no questions, you can say goodbye to the class and I'll see you on next week. No homework, focus on other things. Okay, no homework, practice on your own. So this is long method. This is easy method. Okay. Bye everybody. Everyone is still here, I assume. Okay, I hope you saw the last thing that I wrote and nothing is obstructing it on the screen. Okay. All right. Bye. Okay, Nakita, got your